In this video, you will learn about increasing and decreasing functions. These fall under AS Level Differentiation, that's pure 1 mathematics. So subscribe and let's get into the video. So when we talk of an increasing function, we're talking of a function that has a positive gradient at all times. So let's use the graph of y equals x squared, for example. When we look at this as the function y is equal to x squared, and I'm just going to split it in half, cut it at its turning point. Right, when we look at the right side of this function, if we were to draw a tangent at any point, for example at this point over here, we can tell that our line is slanted this way, which would mean that our line is going to have a positive gradient. So at any point you decide to draw a tangent on this side of the function, we're going to get a positive gradient. This means that if we wanted to find, say for example, f of x is equal to x squared for x is greater than 0, which is this turning point here as coordinates 0, 0. So for x is greater than 0, it means we only have the part that's like this, and this part has a positive gradient. At any point you decide to draw a tangent, this means that this function is an increasing function. So an increasing function is any function that always has a positive gradient. Then when we talk of a decreasing function, it's the exact opposite. So for example, if we draw the other side of the graph, you notice that the way our line is slanted means that it has a negative gradient. So at any point you draw a tangent on this curve, let's call this g of x, and this is x squared and x is less than 0. At any point on this curve, our gradient will be negative, and this means that this is a decreasing function. So when we talk of an increasing function, we're saying that the gradient, which in other words can be referred to as dy dx, is greater than 0 for an increasing function. Then for a decreasing function, the gradient dy dx is less than 0. So in a nutshell, that's all that it is. An increasing function has a positive gradient, a decreasing function has a negative gradient. Let's look at an example past paper question. The function f is defined by f of x is equal to 1 over 3x plus 2 plus x squared for x is less than negative 1. Determine whether f is an increasing function, a decreasing function, or neither. So to check whether it's an increasing function, decreasing function, or neither, we simply have to check whether the gradient is positive or negative. So the gradient in this case is f prime of x, or in other words, the first derivative. So we're told that f of x is equal to, that is 3x plus 2 to the power negative 1 plus x squared. So if we differentiate that, f prime of x is equal to, bring down the power, negative 3x plus 2 minus 2 times 3 plus 2x. So f prime of x is equal to negative 3x plus 2 to the negative 2 plus 2x, and we can write this as f prime of x is equal to negative 3 over 3x plus 2 squared plus 2x. Okay, so now we also have to state our domain. This is going to be very crucial. X is less than negative 1. Now that we have our gradient function over here, we need to check whether this gradient function will always be positive or negative or neither. So if we look at the first part over here, what you notice is that our denominator is squared. So that means for all values of x, this part, the first term, will always be negative because of this negative sign in the numerator. Since the denominator is squared, the denominator will always be positive, and since there's a negative sign in the numerator, it means the overall fraction will be negative. And we have been told that x is less than -1. So it means when we substitute values less than -1, so that's any value smaller than -1, for example -2, it means this part, this term, will also always be negative. As a result, it means f prime of x will always be less than 0. F prime of x will always be negative. This means that this is a decreasing function. So the argument that you have to make is that in the first term, the denominator is squared, so for all values of x, the denominator is positive. In the numerator, we have a negative sign, so that means overall the fraction will be negative. And for the second term, the 2x, our x values are less than -1, so whatever value we substitute that's less than -1, it will always yield a negative value for 2x, meaning that the overall f prime of x will always be less than 0. Hence, f of x is a decreasing function, and that would be our final answer. So that's it for today's video. If you enjoyed the video, like and subscribe. Thank you for watching. Bye bye.